Hey folks, welcome back to Advent of Code in F Sharp, day 11. For the occasion, I dressed up nicely. I got my Advent of Code swag. Let's do that again. I've got my Advent of Code swag, which I won last year. We all every year we do this little company event where we kind of try to get as many stars for the Advent. And we had some swag, which is always fun. But let's dive into some coding. As you can see, I'm still working on part 10 actually. The puzzle was harder, but not super hard, but I had a lot of problems with part 1. I kept confusing rows and columns, and yeah, it's taken a bit longer than I expect. But we're getting there. But let's just move on. Let's get with the program and let's take a look at day 11 today. Cosmic expansion. You continue following signs for the hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe we can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image. The image includes empty spaces and galaxies. Okay. We're trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. Okay, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. The universe expanded, cool. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should be twice as big. Twice as big, so it's not only growing, it's doubling. So we have columns and rows that don't contain any galaxies, and those double. Doubling a single row is making it 2 rows and column, vice versa. So where we had 1 space between here, now we have 2 spaces. Yeah, okay, makes sense. Equipped with this expanded universe, then we have to calculate shortest path. Shortest path is, I see 36 pairs, so we have to calculate all paths for all vertices. Shortest path between 5 and 9 is 9. 1, 2, 3, 4, that's Hamming distance, right? It's taking the horizontal and vertical distances. Is that called Hamming? Or is it the taxi thing? Nah, it's not really. Manhattan, that's what I'm looking for. I did not know Google showed me where I live. Goodbye, privacy. Manhattan distance, that's what I'm looking for. So you count the number of rows and columns difference, and that's the Manhattan distance between 2 pairs. So very clear. Actually very clear. Let's take a look at the scope of our problem. Very doable. Yeah, Manhattan is very doable for this amount of galaxies. I'm gonna quickly drop my input somewhere, and then let's grab the example as well. What's the starting example? Just the first graphic. And let's have a little think about how we would like to solve this problem. I'm gonna do a bit of formatting so it aligns a bit more nicely. Yes, sure. There we go. So we have a grid. We have some galaxies on a 2D grid. We have to expand the galaxy, and then we have to calculate distances for every pair out there. That sounds like all the steps we need to take. So let's first try to figure out, wait, is that a good idea? What if we just have the locations of the galaxies Could we figure out how we should expand that universe? I think we could. Part 2 will probably have us expand a lot more, but let's not worry about that right now. What do we need to be able to do? We need to know where galaxies are, and we need to know what's an empty row or an empty column. If we know the location of every galaxy and we know the bounds of our image, we can figure out all the empty columns and rows. I think so. So I think for data structure today, just a list or whatever, a collection of all our galaxy locations would be enough. So let's try that. Yeah, let's try that. Let's find the locations of the galaxies. So let's write a parse function that takes input and it returns our galaxy map. And that's just a list of locations. Or a list? Yeah, let's start with a list. So it's a list of 2D locations. And that contains our galaxy coordinates. How will we do that? We could just loop over the indices and check. Yeah, let's actually do that. And let's use something we used yesterday, but I have not uploaded a video, so this is new. Let's use a computation expression, which is a very fancy way, or word, for some kind of a thing in F# that you can use for a lot of things. There are many different computation expressions. You have async, you have task, you have maybe, sometimes people use it, you have result, you have, and the thing we're going to use today, a sequence. A sequence is like you define a block like this, a sequence, a computation expression, and in there you can write some code, but the end result of this entire block will be that a sequence is generated. So I can actually assign this to a let binding. So that's, for example, galaxies. And this will return a sequence of something. So now it's a sequence of objects, but if I say in this computation expression, if I say, okay, yield me something, for example, yield me the number 1. And let's satisfy the compiler. We're returning a galaxy map, so that's just a list. There we go. So this block of code will now generate a sequence containing the number 1. That's not very interesting, but it gets cool because in this computation expression, you can write code. You can do a lot of things. You can nest sequence generation. You can write if statements, which is what I would like to use here. So in the sequence expression, I would like to loop over everything. And if it's a galaxy, then we can return the current coordinates, and otherwise we just continue on. So this is this is how you do it for sequences. We have actually seen how to do it for lists, and it's this magic here, 4x in whatever. This is actually very similar. So this is doing the exact same thing, but the return type of this thing is a list and not a sequence. So actually I think those two are similar, if not almost the same, except that we have a little bit less freedom of what keywords we can use in here, I think. We can't really do a bind, but yeah, that's going too far into the details. So this is somewhat similar to sequence computation expressions, the sequence thing. But I think this is less alien, to me at least. So I'm gonna start off with this one and see how far we get. So I would like to loop over my lines in my input, but I would like to keep track of the index. We've already seen this. We can use a map I function, so let's try that. So for row number and row in our input, but we index it. So now we have our, I said map I, but the index is just something similar. It takes a list and it returns a list where every element has the index prepended. So now we have row numbers and the actual rows. And we have to go one level deeper. Same thing for columns. And we can also index that one. Those are strings, so I think if I do a sequence to list on it, we can just feed in whatever we want, and then we can just keep it symmetrical. So yeah, let's do this. And now the fun part, we have our row number, column number, and our cell. So if our cell equals the galaxy, then we are interested in this coordinate, so we can return the column number and the row number. And otherwise we yield nothing. So that's implicit, there's no else statement. So I think if we do this, we are actually parsing into our galaxy map. Let's give this a run for the example. So let's parse the example. 0, 3, 0, 1, 2, 3. Yeah, okay, that quick check looks correct. So that's the map. And now we need to expand our universe. What was the correct terminology? Yeah, space expands. Okay, so in order to expand space, we need to find all empty columns. Wait, let me do a quick double check. Are there empty slots to the left and to the right? Or are all our borders, do they contain a galaxy? There's a galaxy. There's a galaxy. There's a galaxy. And there's a galaxy. Okay, that's an assumption we can use to do the expanding a bit easier. So, what's my thinking here? Figure out all the empty columns. We can do that because we know the locations or the x coordinates of every galaxy. So we just take every x coordinate and we look for the gaps. Yeah, that should be the 3 columns. So let's try that first. Empty columns. Let's map. Take every x coordinate. That's the column, yeah. This is what I was struggling with very much on day 10, and that's why I have not uploaded my video yet. I kept swapping columns and rows in my 2D matrix lookup thing, and it was horrible. I will spare you the full upload. I will upload the summary, but this was not a pretty weekend for me. Okay, but let's figure out our empty columns. So these are all the columns. Is it true that there's 2 on 9? I'm doing it again. My x coordinate is row and not column. Yes, let's make x our column and y our row. Famous last words, because this is exactly what tripped me up yesterday. So column 3, 0, 1, 2, 3, row 0. Yeah. Let's put that in here. X is horizontal is column, Y is vertical is row. Yeah, okay, cool. So now we have all our empty columns, and this looks more to what I expect. So there's 2 on the left, that is correct, and there's 1 on the top. Yeah, okay. So if we have all our column numbers, let's distinct them, let's sort them. Not actually necessary. What do we need? We need to find all the gaps in there. So let's find the lowest and let's find our bounds, which is 0 and in our example 9, but yeah, I don't think this will hurt performance-wise, so let's just calculate it every time. So minimum is 0, let max equals empty columns, source construct, what the hell was that? I type EC and it gives me source construct flags as first recommendations. Let's not. And I want the maximum column value, which is 9. It's the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so it's the max. These stay very stable, right? No, they don't. Our galaxy expands, so we kind of have to calculate the max. I'm already thinking way ahead. I think maybe in part 2 we might expand a bit more than once, and that's a bad habit. So let's not do that actually. So let's keep it at just the one expansion. We have our bounds, we have our galaxy columns. So now we can figure out the columns where we have no galaxy. This is not an empty column, but the other way around. What is this? What's the non-empty? Occupied. So these are all the columns where we have a galaxy, and our empty columns is 0 or min to max, and it's every index in there that's not in our occupied columns. I think I can just do except. So everything except what's in the occupied columns list. That's not the fastest of calculations because it's going over every list, but we have 2, 5, and 8. 0, 1, 2, 3, 4, and 5, 6, 7, and 8. Yeah, that's correct. So this is how I calculate empty columns. Empty rows will be very similar, but yeah. What's the next step? Do we do empty rows or do we do expansion of columns? Let's do rows. So let's find empty rows columns. Given a map gives me a tuple containing the columns and the rows. Rows are, it's very similar. I'm just gonna duplicate my code, occupied rows. Yeah, I'm just gonna duplicate everything actually. Rule of 3. Whoa, what's happening? I copied a bit too much here. So yeah. I'm just gonna copy paste this thing and let's tweak it so it's occupied rows. And those are the y coordinates. Let's double check. Yeah. Max rows is occupied rows. We take the max one. Empty rows is same. And we can just return them. And let's do a quick cross check of those empty rows. Let's do the actual example stuff below, and let's do find of map 25837. It's only 2, 0, 1, 2, 3, 4, 5, 6, 7. That's correct. So we have our empty columns, empty rows. Now we can start expanding. Expanding. We need to take every column and our row, and for our columns we just push everything to the right of this empty column up by 1. Sounds good. So maybe it makes sense to sort our... Actually, no. Yes, it makes sense to sort, but it's a one-dimensional list right now, and we need to shift on the row and this column, not everything to the right of this list. It's a 2D array. Okay, if just for the one expansion, it's just looping over those 2 very short lists, and our input it might be a bit longer, but I don't think much longer. Let's verify. Yeah, okay, so that's not a lot of data. I'm just gonna do the silly thing, keep our data structures very simple like this, and just go over them one by one and go over the full map. Not the fastest way, but it'll work. So for every empty column, I'm gonna fold. Fold. Our state will be our map, just our map. And our element will be our column number. And we are going to expand the map starting from column number. And I'm already just gonna shove in the other coordinates so we can make a one expand function that works in both directions. And the initial state our fold function needs is just the original map. And now we need to declare our expand function. Map x column row. Oh, that's very confusing. Axis column, yeah. And it returns an updated map. Cool. How do we update the map? We need to go over the entire map because they're unordered. So maybe this is the day we do the 4 comprehensions all the way. So we can do something similar to update our map. Let me explain. So I'm going to loop over every galaxy column, galaxy row in my map. So this is identity function. This just maps the original map to the itself, basically. Which is not very interesting, but now we can do some stuff in here. So for example, if the galaxy column is to the right of the empty column, then we shift it by 1 to the right. And this works if you're not doing too fancy, but this arrow does not work if you have if statements in there, and then you have to return to the not so syntactically sugared do yield syntax. It's actually exactly the same thing, but then you can plug in some if statements and stuff like that. So the arrow is shorthand for when you don't do fancy stuff. As we had... Oh no, we had no error today. So this, I think, is expanding our columns, but we also can do the... Oh yeah, I did the row already, but the row... okay, so let's do the calculation. Next column is... And we can do the if statement beforehand. So if we exceed, then gc plus 1, or let's call it call diff. Let's call it call diff. Is it actually? Yeah. So if we exceed, then the difference is 1, else the difference is 0. We can do the same for the row. So if the row exceeds, if the galaxy row exceeds the row of the empty thing, diff for the row is 1 and otherwise it's 0, and we can just always yield the diffs. There we go. Do we still need do yield? We don't. Okay, so maybe, just maybe, this is a maybe this is how you expand. So this is expanding columns. Yes. So let's try that out. Stuff is happening. This one is expanded to 0, 4. What's the trickier one? This one expands 2 to the right, 1 downwards. So that's 0, 1, 2, 3, 4 in the y coordinate. That becomes a 6. I don't see a 6 in there. 1, 2, 3, 4, 5. I am off by 1. So that's a 5. And a 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 5, something like that. Don't see it. Don't see it. Not sure. Not sure. So 4, 0, that is correct. 1, 2, 3 becomes a 4. Yes, that's correct. This one is 1 and then something. So what's the original map here? 7, 1, probably that's the one. 7, 1 should become 8, 1. Oh, but we are not mapping rows yet. I'm sorry. Silly me. So this is mapping just the columns, or it expanding. What the hell is server prompt? Are you okay, F sharp? Let's let's reset. I've never seen server prompt. Okay. So we are now expanding our columns. Let's expand our rows as well. So this is expanded. And let's do row expansion, which is the same thing, but we take our expanded rows, not columns, which is very clear in this two-letter variable. And we map the row num. Maybe we could have done the tuple thing before. We could have put all columns and rows into one list, but okay. Instead of working on the original map, we need to thread through our expanded columns map. And I think this expands both rows and columns. Does it though? 0, 6, 0 does not sound very correct. That sounds very incorrect actually. So the first cell is a 4, 0, and then when I expand my rows, it should not impact my column. And the X is the column, right? Yes, very much. So there's a bug in there. Yeah, that should remain at 4, 0. What's happening? Not seeing it. We've provided with 0 row num. Row num is 3. Three is less than 4. I'm sorry, less than 0 even. More than 0. Why is it plusing 2? That's maybe the correct question to ask. We have a 4, 0. So this part, I am semi-sure that it works. So 7, 1. What does 7, 1 become actually? What's happening over there? 4, 9 becomes 5, 12. That does not sound correct actually. I think we have a bug in our expanding logic. If our offset of the empty row is smaller than the location of our galaxy, then bump by 1. I don't see it. I don't see it. Okay, but let's take a look at our map. Let's go over it. So how many, oh, threw something away. How many of these galaxies should be bumping? This one should be bumping. Let's put our graphic next to it. So what's our original map again? 3, 0, 0. 7, 1, 0, 2. Yeah, so it just parses from top to bottom. So that's easy to work with. So this one bumps to 0, 4. That one we've double checked already. That looked correct. Then we should have Instead of 7, 1, we should have 8, 9, 1. Why is there 10, 4 in there? What even is this? How do we go from 10, 4 to, or from 7, 1 to 10, 4? So let's troubleshoot that case. We have a 7, 1. And we have offsets of 2, 5, 8. For columns, the columns were X. Columns were X. Columns were X. There's 2 less here, so it should be bumping. I just know that I'm flipping rows and columns again. This has become impossible for me to do. I don't understand what's short-circuiting my brain this much. Okay, let's have a look here. Our empty columns, 2, 5, 8. That is correct. Our map is in row 1, column 7, which is 7, 1. Yes. Columns are horizontal are the first component of the tuple. So this is my column. And the empty columns are 2 and 5. It should be bumping 2. What am I saying? It is bumping 2. So yeah, these 2 should bump my 7 to a 9. To a 9. It's not bumping to a 9, right? No, it's bumping to 10, 4. How? So it's looping over our map, it's looping over this one, and it's saying, what's my call difference? 2 is smaller than 7, so it's a 1. Row is 0, so it's not smaller, so that should stay the same. I don't see where this row bumping is coming from. It appears to trigger this row diff every time. And I'm providing 0 for my offset here. Of course, 0 is smaller than all the things. So this is the problem. The 0, no. The 0, no. Yeah, that's the problem. We should not be plugging in a 0 here. So that solves my 4. Where's the 10 coming from? That looks like it's not doing the correct thing once we see an 8. Let's fix this first. Where's my max value? I'm just gonna hack it and just provide a max value. Why is that not working? Is it a function? Oh, that's not the max value. Where's max value? There we go. So not really happy with that, how this design is evolving, but okay. There we go. So one step closer, but not there yet. This might actually work for our, unmatched parentheses. Yeah, we introduced a new parenthesis. Okay, now everything is compiling again. Columns expanded. 10, 1, 10, 1, 10, 1, 10, 1. No, should be 9, 1, right? Should be 9, 1, I think. What? What? Oh, come on. I thought regular expressions would be the bane of my Advent of Code 2023, but it appears that it's X and Y coordinates. How can something this simple be this incorrect? Yeah, if all else fails, I start just hammering out some tests. So let's do that. Let's try to expand stuff. So we are having problems with 7-1, right? And we're actually, this is the actual expansion logic. This is just the sub part of it, but I think the bug is maybe, not sure, in the expand function. So let's first take a look at that. So let's expand with whatever. What's the first example? Let's take actual examples. A 2, and a max value. Was I being too clever for my own good by trying to do the expand for both directions at the same time, or in one singular function? To be continued. So let's call our shot here. What do we expect to happen if there is a column, an empty column of 2, and there is a thing, a galaxy in column 7? We expect it to bump to 8, right? And we expect the row number to stay the same. So I'm calling my shot that this should work. It is working. Okay, next problem that we saw, 8. If we try to expand within 8, it should not shift 7-1. It is not shifting 7-1? Oh. Our fold is actually changing the world in between. Our fold is changing the world in between. So our 7 bumps to an 8 after the first column expansion, but then it's available for the next one. So yeah, the bug is not in expand. I'm kind of convinced myself of that right now. I think the bug is just that we're folding and we shouldn't be folding, because that keeps track of the intermediate rows while going to the next column to expand, and that's not really what's asked of us. So we need to take a slightly different approach. Yes, we need to take a slightly different approach. The columns to expand is still the same. Folding is not really the same. Instead, we should just we can do the other way around. For every entry in the map, figure out what the new offset should be. Yeah, so that's mapping instead of folding. So that is a map. Map.list map. And that's a galaxy, and we can expand a single galaxy. So I'm sorry, expand function, but you have just become obsolete. We have to expand the galaxy by the offsets. And now it's starting to make sense to have all the offsets in one list. We can actually do that, right? We can do this magic, or we can work with some options. Let's keep it simple and let's do this magic. So let's build our list of full offsets. Am I going to regret this? Yeah, let's not. Let's keep it simple. So let's just do column expansion first again and row expansion second. So I'm forgetting this even existed. Let bygones be bygones. And let's write an expand. Yeah, so we are mapping over our galaxies. We're trying to expand galaxy with our columns. And let's write that function. Row column or column row? It's horizontal is column is X. So it's column row, galaxy column, galaxy row. And that gives me a new version of this galaxy. So something like this. Okay, now we can do the thing. We can actually do the thing. So we figure out How many of these empty columns are to my left? So that's a filter. Empties. List count by. No, let's filter first. And that's a column row tuple. And if the column is to my left, we keep it and we count it. So that's the amount of empties to my left, and that's my diff. We have a type problem. Oh, empty columns is an int list, so we don't have to destructure here. It's just a column number. Yes, no, yes. Okay, so that's expanding columns. Let's take a look at this. (9.1). I like to see 9.1. I think that's more correct than what we were doing before. So we can expand columns. I'm not even going to think about making this generic or whatever. Let's keep it very literal. Galaxies, empties, diff. We need to take a look at the rows here. Galaxy row, and we have to diff the row, of course, not the column. So this works. We can slot this in the pipeline, expand rows. Is that now correct? First we can do the columns, and then on that intermediate result we can do the rows. Yeah, I think so. And it's the empty rows, of course. There we go. We can get rid of some syntax if we really want to. Not sure if I prefer this one. And that's the fully expanded map. Cool. 4091, yada, yada, yada. Probably correct. Probably correct. If you have the expanded map, then it's just a matter of calculating the shortest path between every pair. And that's actually not the hardest of problems if you just need Manhattan distance. So let's find every pair. I think there's a built-in function since a couple of years. I think this is a pretty new one. Let's see what all pairs does. If we take a list from 1 to 3, I would expect 1, 2, 2, 3, 1, 3. Oh no. What? That's not all the pairs. Yeah, no, that takes 2 lists. So is there a combinations? Is there a function that sounds like that should be a, maybe not built in, but that should be a permutations of it. That's not, no, that's definitely not what we want, I'm sorry. And that's given a permutation function. So yeah, no, let's quickly write our give me all combinations. Without having the inverse of a combination and without having duplicates. Yeah. Let's write a combinations function. For x in x's, and then you know what? I'm gonna just do the naive, or the thing I know how to do with indices. So let max. I need 2 indices, right? I need to count from 0, and then I need to count from the element. What's the functional way to do this? I don't care. I want to get it done. We've been working for 45 minutes now, and my workday has yet to start. So let's just hammer it out. What do I actually want? I want the element, and then for the second pair of my combination, I want to compare it to every element to the right of x. So I don't want x's here. I want, so this will generate some doubles. We can show that. So the combinations of a list of 1 to 3 gives me a lot of things, but that's way too much. And that's because our y starts at 0 for every x, and we actually have to only start this up to the right of x. So we can just say skip something, and the something is the index of x. So yeah, let's just index. This is starting to look like procedural code, but no worries. So yeah, and we start at something like this. Let's verify. And not itself would also be cool. Why is it doing itself? Skip 0. Yeah, okay. This I was not correct. One, two, 1, 3, 2, 3. I think this is it actually. Cool. That was hopefully more straightforward. I hope this is it. Can I do arrow syntax? I can. But I don't like it. Let's keep it symmetrical. There we go. We have our combinations function. We can put combinations around our expanded map. This is our pairs. Pairs in our expanded map. Sorry, combinations. There we go. So how many combinations should we have for the example? 36. 36, correct. So now we can calculate Manhattan distance, which is pretty easy. Yes, it's pretty easy. So distance between galaxy 1 column, galaxy 1 row, and galaxy 2 column, galaxy 2 row is a length. So that's absolute value of the difference between one column comparison. So that's column distance, and we can compute row distance as well. And that should be the Manhattan distance. So we can map our pairs one other to the Manhattan distance between one and other. That gives us a list of all the Manhattan distances for these pairs, and we can just sum them up. And we get something in the 374 range, which is correct. So let's try this for our input. Let's try it out. Pretty confident. I think we bashed through my XY incapability of getting XY correct. So this pairs, I'm just gonna put a result in there. Pairs is even better. Yeah, so this works, for example. Let's see if this works for input. Building our map is fast, finding empty stuff is fast, expanding is fast, finding combinations is fast. So yeah, everything works. There we go. We get a big-ish number. It's correct. Cool. Let's take a quick look at part 2. But I'm hitting on my time limit for today, so this might just be a case of if it's easy, we can do it. If it's hard, we do it later today. Probably we will be expanding a bit more. Yeah, make each empty row or column 1 million times larger. Sounds like a basic thing to do. Famous last words. Oh no, we're No, that's actually pretty doable. What's the problem? Okay, an example above, if each empty row were merely 10 times larger, the sum would be 10, 30, 100 times. It sounds like the naive thing is not the correct thing. If they're only taking steps of 10 and 100 in the small example. Yeah, so I think this warrants some thinking time before we do some programming time. And that I am fresh out of today. So I'm going to call it quits here, and we'll continue for part 2 later on. Let's do a quick recap of day 11, part 1. What did we do today? We expanded galaxies and we calculated the distances, for part 1 at least. How did we tackle today's problem? We used some 4 comprehensions again, and the fancy-ish thing was you can do an if statement in there, so you don't generate elements for every element you are looping over. So it's a filter map. You're doing both mapping and filtering in one expression. So that was handy. Finding the empty things, we just used some utility functions we have not seen yet, like the except to calculate list differences. Then we had a lot of problems with rows and columns. Yet again, it will be the end of me this year. I tried to be smarter than I am by combining the column and row expansion into one function. I think it's very doable. I just was not up to it today. But we just did the expansion. And we wrote our own combinations function, which I find a bit puzzling, that it's not built in somewhere, but it's not really hard if you know how to do it. And then we used Manhattan distance. That's also a staple of Advent of Code puzzles. So that's something that should be in your toolbox if you do a lot of these. And yeah, that's it. We parse, we find empty rows, we expand, calculate combinations, calculate distances. And for part 2, we'll see later today. Thanks for watching, and I'll see you again for Advent of Code in F#. Bye-bye.